Hey there, in this video I'll show you step by step how to build an RAG pipeline in Python from scratch. But first of all, let me explain what RAG actually is. Imagine you need to build a chatbot for an airline's website. You will likely use some light and cheap LLMs like GPT-4o or Claude Haiku. But here's the problem. Users will likely ask questions related to a specific flight and maybe related to an airline's general policy. But how do we teach an LLM about those policies and give data about a specific flight? We could give all the data including policies to the LLM as a part of prompt, but the problem is you will need to include, let's say 3,000 words in each request. In that case, the airline will likely end up like Uber and never ever implement AI again. Here's where comes RAG, or Retrieval Augmented Generation. It's basically giving an LLM the most relatable chunks of data. In this example, the data about a specific flight and the whole airline's policy will be chunked into, let's say, 500 character chunks. Then, we will need to embed those chunks, which means getting vectors for those chunks. Vectors or embeddings are like numerical or vectorized representations of the semantic meaning of a chunk. One embedding can consist of 1.5 or 2,000 numbers. We will store all those embeddings in a vector database. Now, let's say the user asks a chatbot a question about the refund policy. We need to get the embedding of a user's request first and do the search in the vector database to find the most relatable and number of chunks. And we give those chunks to an LLM as instructions. Congratulations, you've just built an RAG pipeline. Alright, now let's get into the actual code. I'll walk you through it step by step. At the top, we import our three main libraries. We have the Anthropic client for Claude, the OpenAI client, and yes, we're using OpenAI here, but only for embeddings, not for the LLM itself, and ChromaDB, which is our vector database. We also import PDF reader from PyPDF to read our PDF file. Then we initialize the clients of OpenAI, Anthropic, and ChromaDB. Now, the first important function is getEmbedding. This takes a piece of text and returns its vector embedding using OpenAI's text embedding 3-small model. This is where we actually generate the vectors that we talked about earlier. Next is extract text from PDF organize. And sorry for this long name. This reads the PDF file page by page and returns a list of dictionaries where each dictionary contains the page number and the extracted text. We keep track of page numbers because we want to be able to reference them later in Claude's answers. Then we have chunk text. This splits a long piece of text into smaller overlapping chunks. We use a default chunk size of 500 characters with 100 characters of overlap. The overlap is important. It makes sure that if a sentence gets cut off at the end of a chunk, it still appears at the beginning of the next one, so we don't lose the context. Now comes the indexing phase. We create a ChromaDB collection called PDF base. Think of this as our vector database table. Then we load the PDF, loop through every page, chunk the text, generate an embedding for each chunk, and store everything in the collection. We skip chunks shorter than 50 characters because they're usually just noise, like page numbers, headers, that kind of thing. Finally, the ask question function is where it all comes together. When the user asks a question, we first embed the question using the same model we used for the chunks. Then we query ChromaDB for the 3 most similar chunks. We build a context string from those chunks, including their page numbers, and pass everything to Claude, with a prompt asking it to answer the question based on those excerpts. Claude then returns the answer with page references. And that's the full pipeline, from PDF to embeddings to retrieval to a Claude-powered answer. You might say that RAG is not the only way to give an LLM necessary context, and you're right. There is a prompt engineering and fine-tuning option. We already know why prompt engineering wouldn't be a good fit in this case, but it is a good way to change the behavior and style of responses. Fine-tuning will be an extreme option because it needs weights to be adjusted, and there is a lot of work involved that is not necessary. So RAG is something in the middle, and that's exactly what we need. Now, there are some flaws of RAG too. For example, sometimes you might need keyword search instead of semantic search. And remember, they can bear totally different results. For those cases, there is a hybrid search RAG. There's also a hypothetical document embedding in which LLM itself first fakes or tries to answer the question and then uses embedding of that answer to look for the real one in the documents. Let me know in the comments if you want me to cover those as well. And that's it for this video. Thanks for watching. See you in the next videos.